We're going to move into the presentation from Doug McDonald, focused on Objective 5.2, which is centered around integrating wetlands and their role as carbon sinks, greenhouse gas emitters in terms of our national inventory. I think most of you who attended the AGM last year probably had an opportunity to meet Doug. And so just a little bit about Doug. He's the section head for the Agriculture, Forestry, and other land use initiative within Environment and Climate Change Canada. And he works at the Science Policy Interface, supervising a scientific group that's responsible for the preparation and publication and coordination of the research to produce the national estimates that go into Canada's national greenhouse gas inventory reporting that are required under our commitments to the UNFCCC. Doug has, also routinely participates in IPCC task force group meetings and has been absolutely critical and instrumental in providing advice and shepherding this project along to make sure that we're producing information that is going to be usable in terms of national greenhouse gas inventory reporting. For those of you who do not know Doug, and I think I've got this correct, but so Doug is originally from the Canadian Prairies, so grew up in the Prairie Pothole region, I believe, an area near and dear to my heart. And if I'm not mistaken, is still a Winnipeg Jets fan, who are currently #1 in the league, entering in the playoffs shortly. So I don't think we were as positive last year when we met at the AGM after kind of the dismal playoff performance, but hopefully things go better this year. And so with that, I'm going to hand it over to Doug.
Now you've distracted me, though. Now I'm thinking, Jets. How am I ever going to get through this presentation now? All right. Thanks, Pascal. And so I'm going to be talking about something that's like quite simplistic when it comes right down to it, quite simplistic and also quite complicated compared to everything that Irina just threw at you. I'll hopefully have a little bit of time at the end to address some of the points that Irina made that may be somewhat erroneous, but we can talk about that offline as well, Irina. So, if I can just... So, agricultural drainage. Obviously, drainage is still common practice across Canada. It's not currently reported in our inventory. That's mainly due to a lack of authoritative estimates about the rate of wetland loss and the types of wetland loss and the characteristics of wetlands that are being lost due to agricultural drainage. There's also a lot of complicated things about drainage. First of all, it's not just drainage, it's also consolidation. So there's an overlap between the different ways we want to report that. So in a certain sense, while it's drainage, it's also flooding. We also, due to discussions with Pascal, discovered a lot of, I guess, what you call informal dams that have been established through the Prairie Pothole region, which is going to also complicate some of our analysis and some of our implementation. And then when we start to look at other areas, as well as the prairie potholes, this is becoming more common, but it's complex watershed scale effects that are coming from tile drainage that are really hard to quantify in terms of their impacts. And when I talk about impacts, I'm talking about land use change, right? So we're not talking about indirect impacts from all of the other things that are going on in the environment. So things like ammonia deposition, climate change itself. What we're talking about is land use change, where the use of an area of land, is changed to another use, or its management has changed. IPCC methodologies try to keep things simple. It's about tracking carbon from perspective of the emissions of carbon dioxide. So we have a fixed pool of terrestrial carbon, and we try to estimate how the carbon moves through that ecosystem and how much is released or taken up annually from the atmosphere, to and from the atmosphere. And my group in Environment Canada, we mainly focus on, as I said, land use change, and we have a generic system that we try to apply that applies the IPCC guidelines that implements the impacts of a land use change event. So this obviously has to start off with activity data. So we're capturing the area of land that is undergoing a change. We start with pre-disturbance carbon pools, uh, biomass, dead organic matter to a certain extent. Sometimes this occurs in some ecosystems, other times not. And then the soil pool. And we have a number of disturbance matrices that we can apply when these different pools are applied. And the final part of the picture is the actual emission rates. You can call them emission factors, they can be functions. The way that carbon dioxide is being released through different processes, whether it be decomposition, combustion, or some other process. How do we derive the emission rates? They're derived from sometimes model estimates, ideally field estimates. Sometimes these are paired analyses, so comparative analyses that end up developing our ability to capture the change in state from the previous land use to the future land use. But some sort of a method that has created a sound understanding of the change that's occurred in the total carbon that's occurring on the managed landscape. One of the complicated things, as I was saying, with wetlands is you've got these combination of effects. And I'm talking mainly about the prairie potholes because this is what we've been focused on in our work with Irina. But at the same time as you have drainage, you're also seeing the occurrence of flooding and the impacts of flooding. So Irina completed a research project with us in 2024. And the beginning of 2024. So that's basically a year ago today. And it's kind of our state of knowledge study. So what we asked her to do is basically to compile all the information that she could on prairie pothole region in context of some of the studies that they were doing using doing some isotope analysis. The studies that attracted us to Irina's research program. And so I've divided this into sort of the different features of how we do a calculation for a greenhouse gas estimate. So starting off with activity data. So from that, we recognize that, activity data is still the most difficult aspect of capturing the impacts of agricultural drainage on wetlands. We see that the inundation occurrence approach that David has been developing is promising. We've also understood that the best product to use this type of analysis is this product that's produced by a group from ECCC, the Landscape Science and Technology Division. But we also understood that there's this strong interference between human-induced flooding, so what's occurring in itself from drainage, from climate change effects, so the intensity of storms, and just general changes in hydrological cycles. And this really masks our ability to capture actual drainage, so the actual act of draining the wetlands. And so this has required a lot of additional analysis and solutions. I think David's been working on it on his side. We also have Daniel Idella, who works with us, who's been looking at this closely. So change detection is based on 10-year windows. I hope I'm not repeating. I wasn't there yesterday, so I hope I'm not repeating all the stuff that David talked about. But so we're looking at 10-year windows where we can capture the state between 1990, 2005, 2020. Obviously, that's not a 10-year window, but close enough. Um, and what we're looking at is these peak occurrences of water uh, on the landscape, but also trying to remove these temporary flood conditions, which are masking the actual drainage effects. And this is a good example that Daniel put together. You know, if you look at the 2011 to 2020 layer, if anybody is actually from the prairies, 2011 was one of the biggest flood years on record, right? We actually have problems with the Census of Agriculture data because there was so much flooding in that year that it kind of screwed up the census year. So we have to find a way to weed out those flooding events, which appear as if the surface water on the prairies is actually increasing over time. But in reality, it's that this water is being spread over a much bigger surface in a much thinner layer. And anybody who's familiar with the plains outside of Winnipeg, for example, um, if you get a little bit of a flooding event, it covers a lot of area. And this often confuses some of the analysis that's being done by remote sensing. So when we have done our analysis, where we hope to take this is to estimate the land use change and integrate this into our Soil Landscapes of Canada database. The reason we're doing this is because this is the basis for which we have all land use and land management changes on the agricultural acumen and how the land parameters are compiled by AAFC. So we'll be doing our analysis at this scale, though the rates that we determine are going to be dependent on what we believe is an accurate estimate and not necessarily broken down by or developed at the scale of the landscape, of the soil landscapes. So meaning that if we feel that there's inaccurate information being produced at fine scale, we'll roll aggregate the information until we have a reasonable level of confidence in the results we're producing. And the other thing that came out that's useful from Irina's study is the production of good validation data. So working with Pascal, we've got now the surface ditching index from the Prairie Habitat Monitoring Program, and also looking at with David at a number of different products that we can validate these estimates against and produce a good understanding of the uncertainty that we will have in terms of developing our rate of drainage. So Daniel's developed basically a workflow for this. I'm not going to go through the details of this, but you know, a multi-step process in order that we can arrive at rates of wetland loss across the prairie pothole region and be able to validate this against the best field data and imagery that we can dig up. I'm going to skip through this a little bit, but this just gives you a good understanding of what we're looking at. We have to start our estimates going back to as early as 1970. So, and that's because of some of the emissions that we're going to be seeing from some of the drainage that's occurred pre-1990 are going to be occurring within the 1990 period. So we have to develop this time series of wetland loss that will cover this entire period. And at either end of this, because we're going to be dependent on the Landsat time series, we're going to have to be extrapolating backwards. And in recent years, forwards until we can carry out another periodic analysis. So moving on to a second element of what we need to do these calculations, the soil carbon pool. And Irina's one of her students did a literature review at the time. What we could see is that, the Canadian data that's out there is what I would call sparse and inconsistent. There is not a lot we can do with it. There is really a lack of post-disturbance data. So trying to understand how much carbon is lost over how much time is not really possible with the Canadian data set now. And looking back to the studies, and this, Irina pointed this out in her final report, like often studies didn't even sort of consider some of the basics of soil science, using an equivalent soil mass basis to do comparative studies. So this makes it very difficult to actually develop a good understanding of what's occurring on the landscape when we don't have data. We also noted that the isotope analysis, and I don't know, this might be a point of contention between myself and Irina, but we don't believe that for mineral soils, this is going to give us a good quantitative estimate of rates. What we're seeing in the analyses that are coming out of peat extraction is that the recent data of based on isotopes is needs to be corrected. And for the mineral soils, it appears that probably time period's too short on these types of analyses to really believe the quantitative analysis in it. Fortunately, Shiel's been working really hard for quite a while in the US, and the difference between where he lives and where I grew up, actually in southern Manitoba, is not that great. And the US data has been is going to be incredibly valuable to us, and it has been in terms of all the analysis that we've carried out. Obviously, there's questions of whether this data is really representative of Canadian conditions, because, believe it or not, that border is real and it does have a big impact on how people manage the land. And there's also temperature differences and differences in sort of past management as well. So we do have that question of representativity. And the other thing that really came out of the analysis with the soil carbon pool is the fact that there's a lot of carbon at depth in these sites, and we need to consider all of that carbon in terms of estimating what the carbon loss will be when there's a land conversion. So where we're at is really if we implement a methodology, and we are aiming at implementing a methodology. We had this discussion with the EPA last year, thanks to Shiel, who invited us down to discuss this. They also believe that they can develop and implement a simple methodology for mineral soil wetlands, and I guess in the Western US to start off with. And where we'll be starting with is a tier 1-ish type of methodology. So a tier 1 approach where we're using the rate of loss, which is going to be 29% over 20 years. And that is a default parameter from the IPCC. One of the rare default parameters that is used in the Canadian inventory, I should add, because default parameters are only used for very minor sources in the Canadian inventory. And we can estimate the emissions that are associated with the change that's going to be based on the initial 20 years. And beyond those 20 years, what we will do is we'll work to transfer the wetland sites, the wetland areas into our tier 3 cropland model to continue on with the carbon change in future post 20 years down the road, post 20 years after land conversion. So once again, moving to methane, and this is also an important component of wetlands, obviously. Once again, I think the ultimate result of the analysis that Irina carried out is really that Canadian data is sparse, it's inconsistent, and it's highly uncertain. We have very few measurements of methane from wetlands on the Canadian prairies. They're short term for the most part. I know that Pascal's been working hard on this and that we're starting to get some quality data, but you know, that hasn't developed very far. So we're once again, what we have to rely on is the USGS estimates and the work that Shields done. This leads to the same question of representability, but it does provide us with a fairly good approach to developing as well some spatial differentiation on the methane estimates. What we do need to do, however, on this data is to try to do some validation work and make sure that that the even though the data is sparse at the moment, that we're able to actually capture or better understand how representative the data that Shield has produced is to Canadian conditions. And I think the most important point here is that we don't believe that this data would be less accurate than the current IPCC default. And as Irina mentioned, there's also a big question about how we apply the managed land proxy. Managed land proxy really only applies to carbon and typically applies to forests, but wetlands are kind of a special case. And one of the things that makes it particularly complicated is the question of methane. So I just said that methane emissions the measurements are sparse and highly uncertain. To actually do a managed land proxy on methane means you actually have to produce a methane budget. So do you want to produce a methane budget that is based on sparse measurements and highly uncertain? That's a real question. Our reading of the results of that survey that was carried out was that, there's expert opinion that suggests that the emission profile of wetlands that are occurring in really intensively cropped landscapes are significantly impacted by the surrounding landscape. But the one thing that we noted from that survey is that it was almost entirely based on expert opinion. There was very few measurements, very few proof that was brought forward for this, and it's assumed based on an understanding of processes. There's a lot of fertilizer that goes into these wetlands, and therefore that's having an impact. And that's logical, and we understand that. But once again, not based on measurement necessarily. The thing that we also understood about that is that it's unlikely that the wetlands that are occurring in the more extensively managed landscapes, so some of the unimproved pastures that are just being grazed, and some of the forested areas that occur in the prairie pothole region are likely to have their emission profile that's going to be modified due to the direct management of humans. So they're going to be more similar to natural wetlands. Natural wetlands also being impacted by climate change, also being impacted by ammonia deposition, also being impacted by all of the global processes that are occurring across the planet, as are all natural ecosystems. So, this leads us to how do we report methane from wetlands? And this is a real challenge. What we see is we would be reporting methane now under cropland, remaining cropland. So these would be an actual methane budget. It's scary, uncertain, that would be occurring within the areas of wetlands that are occurring within intensively managed cropland. We'd also have methane emissions from wetlands that are going from unreported to reported. So a shift from unmanaged land to managed land. And this is occurring when there is a land use change, either from forest land to cropland. So when deforestation is occurring, when there's a process of unimproved pasture to cropland, and this is how we quantify the conversion of grassland to cropland in the current inventory. And the unimproved perennial lands to annual crop production. It's dependent on where this is occurring in the prairies, how these are going to be classified. This is going to be reported then as a management change under cropland, remaining cropland. So all of this methane is all going to be reported as a cropland emission. I'll get to the challenges of that later. And then under flooded land, and so we're going to see cropland that's going to be converted to wetlands. This is where we're going to be reporting the occurrence of increased coverage of some of the larger wetlands that are the receivers of water during the consolidation of wetlands. And we think this is really important because policy it varies a lot across the prairies. There's wetland drainage everywhere, but for example, in Manitoba, wetlands are consolidated, and the idea is that they have to be equivalent in the area that that there is no net loss of area of wetland. Whereas in some of the other provinces, there are no rules about how much wetland can be drained. So we do need to differentiate this sort of important element of capturing existing policy, providing science around this. I won't get into the additional requirement. We discussed this with Irina during the research project, but we also need estimates of biomass loss. We have a lot of overlapping work right now with woody biomass analyses that we're doing. So we hope to develop some parameters around total biomass in the prairie potholes through some of the existing work that we're doing. So, quick summary. Sorry, did I go over time already? No? Okay, good. So we are aiming to integrate the estimates into the 2027 National Inventory Report. We're working towards it. It's going to be dependent on resources and time and the complexity, in particularly of the activity data. I think this is still the most significant challenge. It's still the greatest amount of work that we have to do and compile and integrate into other landscape monitoring systems, which is one of the biggest challenges. Just to get back to your point about data management, Irina, it's a problem for everybody. I was recently at an IPCC meeting where it's a problem there too. Our approach is going to be basically a tier 1, but we're going to be integrating country-specific carbon pools into it. And then in part of the post-conversion analysis, We hope to interface the land use change once it's become land remaining land into our tier 3 cropland modeling system. And our methane is going to be a really complex reporting structure. It's going to have a significant impact to cropland reporting, and this is going to be it's going to require a very significant communication strategy in order to make people understand how the impacts of wetlands are being reported and why and how it's being reported in the way that it is being reported. People expect wetlands and impacts to wetlands to be reported under wetlands, like people expect deforestation to be reported under deforestation, but that's not the case. The impacts and the emissions of land use change are reported in the category of the receiving land use. And this often creates some confusion and controversy, which we're going to have to be dealing with as we go forward with this. That's all I've got. Do I have time for questions?
Yeah, I think we can entertain a couple of questions if that makes sense, Irina. I don't know if I'm seeing any in the chat. Oh, looks like Gail has a question, so let's go to Gail first.
I actually because I was making comments in the chat, I decided to put my question in the question and answer part. Sorry to complicate everybody's lives. Yes, methane, Doug. What global warming potential would is going to be used? There are so many, and then there's the one from Neubauer and McGonigal that's a metric for ecosystem based, 10 years, 20 years, 100 years. Because it'd be good as we write up our papers, particularly our grad students, like and we want to do CO2 equivalents. What should we be using?
I only know the one of them. That's the one that's used in reporting. And I know there's a lot of controversy about global warming potentials, particularly in its use in the for biogenic methane. But yeah, I would advise reading some stuff around, for example, some of the controversy around how net zero is being calculated and compared to how inventory reports are being produced. And it's not just there's a lot of complexity to this. And for the moment, within the AR7 or AR6, the global warming potentials for biogenic methane were treated a certain way, or in the AR6, is there differentiation? Anyway, we have to keep up with what is being accepted and what's being produced in the assessment reports by the IPCC. And that's what our GOWP is based on. And it will continue to be.
Using which time frame?
They use the 100-year.
You're using 100-year, okay.
Yeah, and Gail, I think the workshop that was held in Washington last July, I think one of the places we landed at is that, again, so for UNFCCC reporting, you've got to have an apples to apples metric, right? And so they're sticking with the GWP 100. But I think what was discussed is potentially generating in parallel these other metrics, right? Because that allows you to look at different time frames and longer term impacts of these ecosystems so that you can always assess them comparatively against each other. Now, that's not going to go into IPCC reporting, but I see David has a question. We might have to hold off other questions until later. So let's go to David and then maybe save the other questions for either just before lunch or just after lunch.
Okay, thanks, Pascal. Hi, Doug. Interesting presentation. Obviously, there's a few points there that have tweaked interest amongst the group here. I just had one based on what was presented yesterday and your comments about wetlands essentially not really contributing much. And it may have been specific to methane, but I'm curious, with the idea of wetland, does your concept of wetland capture the riparian area, the interface between cropland and the water body? Because if it does, I don't know how you could possibly say there's not information, lots of information and data that shows how there is a very direct and indirect impact of cropland on the wetlands and the wetland nutrient levels, emission levels, et cetera, et cetera.
So that didn't come up in the information that Irene collected. So what we asked for was specific proof, and what we got was a lot of I guess sort of speculation. So I understand what you're saying, and we do consider the perennial or the area around the wetland, so the interface. And we're talking you're talking about prairie potholes, right?
Primarily,
So yeah. So yes, we are considering that. So there is a reduction in obviously the size, but I mean, that's exactly what I'm saying, why we would be considering the wetlands that are in extensively managed areas to be more consistent with wetlands that are occurring in natural areas, unmanaged areas, where there isn't human management, versus those that are within intensively managed areas. I mean, the logic was there. What I was saying is that there wasn't very much like proof, scientific evidence brought forward within that consultation.
So you'd be encouraging and inviting the information from this group to help inform on that front then?
Sure.
Okay.
I mean, when we want, like, there's a lot of confusion about managed and unmanaged areas. The reason you have a managed area is because you want to delineate a specific something that is measured, and you want to measure the change within that area, right? That's what it's all about. It's particularly important in forested areas. The reality is, a lot of our forested areas, we don't actually have any information about them. They've never been inventoried. So why would you expect that area to be inventoried by the greenhouse gas inventory when the provincial forest agencies have never even inventoried them? Like, that would be silly, is what it comes right down to. So a lot of this comes down to that question, but it's also a question of whether we are having a direct impact on it and whether we can measure that impact. And there's a lot of global impacts on ecosystems. We understand that. You know, that's globally understood. But how do we measure specific impacts, direct impacts of decision-making processes by people who are managing the land? That's the question. And that's what we're trying to get to in a greenhouse gas inventory. Not
Great.
sure I responded to your question, but
Oh, yeah, you did. I know, and I understand and appreciate how absolutely complex this whole system is when you start to do these calculations. So I appreciate that. But I was just wondering, because there's an opportunity, if we can provide information to build up in like knowledge and data on that one element of it, it may actually move the needle on our ability to model and predict what the emissions are.
I mean, you saw my intention going forward is to differentiate managed and unmanaged wetlands. So that's already a controversial step.
Yeah.
I can tell you right now.
Okay.
So any information that's provided that backs that decision, I would appreciate.
Okay.
Yeah, this is great discussion. And I think again, some of the goals obviously of the CAF project are to fill in some of these gaps. And then I always one of the things I have raised previously is unmanaged versus managed. I'm not sure it's as black and white as that, and there's potentially a gradient. So we're already seeing pretty significant impacts with just different land uses, whether we're going from perennial grazing landscapes that surround a wetland relative to croplands. And so already there are definitely differences with respect to greenhouse gas emissions that I think we could incorporate into national greenhouse gas inventory reporting. And those are, will come to light further as we move towards the end of this project.